Welcome to the Deep Dive. Today we're really tearing into modern network security. We're focusing on Zscaler and this architecture called SASE, Secure Access Service Edge. We got quite a bit of material here on how Zscaler evolved from, well, what was basically a web proxy to this full SaaS platform.
That's right. And our mission really is to unpack the why for you. Why are so many companies ditching their old security models? It really started with digital transformation. Apps like Office 365 moving to the cloud, that made the old ways pretty much obsolete overnight.
Oh yeah, I remember the pain point well. This idea of backhauling traffic, everyone working remotely or in branch offices, all their internet traffic had to go all the way back to the main data center through expensive, often slow MPLS links.
Exactly. It just didn't scale. It created these massive performance bottlenecks. You're forcing all this cloud traffic on these long detours, and the cost of constantly upgrading that bandwidth, well, it was unsustainable. So the shift was inevitable, really. You need security closer to the user at that local internet connection.
Okay, so the old centralized firewall model is out. SASE steps in. But, there are so many buzzwords. What is SASE actually providing? What are the core functions?
Right, good question. SASE isn't one product. It's more like a framework delivered from the cloud. It bundles things you used to buy separately. Think URL filtering, SSL decryption, DLP data loss prevention, CASB for securing cloud app usage, and sandboxing for unknown threats, all integrated.
And one thing that really stands out, especially if you're managing the budget, is this idea of hyperscaling. Like, if you suddenly need to support way more users, say you acquire another company, you don't have to physically upgrade hardware appliances, right?
Exactly. That's a huge financial shift. You just buy more licenses for the users or maybe for bandwidth. The underlying cloud infrastructure handles the load. And unlike some cloud models where costs can fluctuate wildly, Zscaler is often fixed per user or per amount of bandwidth. That predictability is incredibly valuable for IT planning.
Okay, let's break down Zscaler's main offerings. First, there's ZIA Zscaler Internet Access. That secures the traffic going out to the internet and SaaS apps.
Correct. ZIA handles that outbound traffic. Users typically run the Zscaler Client Connector, or ZCC. That client sets up what they call Tunnel 2.0, and the key thing is it tunnels all ports and protocols, not just web traffic, so everything is secured consistently.
Got it. And the other big piece is ZPA Zscaler Private Access. This is positioned as the replacement for traditional VPNs. How is it fundamentally different?
This is where zero trust really comes into play. Legacy VPNs, they basically dump you onto the corporate network. You get broad access. ZPA is totally different. It grants access only to specific applications you're authorized for, not the whole network. And crucially, ZPA hides the actual IP address of the internal application from the end user's device. This massively reduces the risk from, say, malware spreading laterally or insider threats.
That makes sense. But if you've got users all over the world connecting to different points of presence, how do you ensure that security policy is consistent everywhere?
That's core to the architecture. Zscaler uses this global network of data centers. They call them Zen nodes, over 150 of them now. They all sync policy from a central authority. So no matter where you connect London, Tokyo, Sao Paulo, you get the exact same security rules applied instantly.
Okay, powerful stuff. But complexity can bring its own problems. We all know users complain about slowness. In this distributed SaaS world, how do IT teams even begin to troubleshoot that? Is it the user's Wi-Fi? The cloud?
Yeah, that's the million-dollar question sometimes. And that's what ZDX Zscaler Digital Experience is designed for. It's a monitoring service. It gives you visibility right down to the end user's machine, checking their Wi-Fi signal, latency, and it traces the path hop by hop across the internet to the application. So you can quickly figure out, okay, is the problem local? Is it the ISP? Or is it something in the Zscaler cloud or the application's cloud?
And we saw some mentions of how this integrates with other network tech, like SD-WAN from vendors like Fortinet. How does that work?
Right, that's a common setup. The SD-WAN appliance at the branch office will typically build secure tunnels, usually IPsec or GRE, to the nearest Zscaler Zen node. Then the SD-WAN directs traffic. Internal private traffic stays on the corporate network or SD-WAN fabric, but all the internet and SaaS traffic gets sent through the tunnel to Zscaler for inspection.
Okay, wrapping this up then, the key takeaways for you, the listener, seem pretty clear. There's potential for serious cost optimization moving away from hardware cycles. You get stronger security through that zero trust model with ZPA, and hopefully better performance with this decentralized, scalable cloud architecture.
Absolutely. And maybe a final thought to leave you with. This ability, especially with ZPA, to completely hide internal applications and base access purely on identity. It really decouples application security from the underlying network infrastructure. So what does that truly mean for application owners and developers when the network itself becomes almost irrelevant to their security posture? That's a fundamental shift to think about.